All right, so let's look at lab 2. So this is kind of after the fact. I realize that some people kind of did it, and they might have to go back in and get screenshots. If this wasn't so foundational on everything we're going to do in this course, I would say don't worry about it. But this really, you guys really have to see the MAC addresses and what's happening and appreciate what's happening when you ping. So if you go into labs, if you go into lab 2, I kind of came up with this whole diatribe on lab 2, how to document it. So, you know, like part 1, clear up the ARP cache. Show me that, because at the end of the day, when you ping, somebody take on what's happening when we ping. Somebody take that for a sticker. What happens when we send out a ping? Somebody describe that. All right, Darren.
You're sending, I don't know the type of packets, but you're sending packets. I think it's
ICMP packets. Okay, so what do I need to form an ICMP packet? That's going to be encapsulated. Okay, so we have the ICMP, and that's going to be encapsulated in what? Not a frame, before a frame. Layer 3, IP packet, right? Okay, now IP packet always has to be encapsulated in a frame, right? Okay, for me to send out a frame, I need what? A legitimate MAC address for the sender, okay, and for the target recipient. Okay, do I have the MAC address for that? Oh my gosh, what do I do? So you go look at the ARP table. You look at the ARP table and you know the IP address, right? Because you ping that IP address. So you look in the ARP table for that IP address, and then you look at that MAC, but is it guaranteed that you're going to have that IP address in there? No. If you don't have that IP address in there, then what do?
send an ARP request.
Send an ARP request out. Okay, so that's going to be a layer 3 ARP message. And then I have to send I have to encapsulate everything in an Ethernet frame. But this time I get a pass. I'm going to send it out as in the ARP packet. I need the destination and the source IP. But what do I put down for the destination MAC address? All zeros. Show me that. Show me that. I want to see that ARP request being an opcode request, opcode 1 request, and I want to see MAC address all zeros. Now I know you know where you're looking at. Okay? In the Ethernet frame, what MAC address am I going to see? All zeros?
All Fs.
All Fs. Why am I seeing all Fs, David? It's a broadcast message. What does that mean?
That means everybody's going to get it.
That means it's going to hit the switch and the crap's going to hit the fan, right? So it's going to hit and go everywhere. Anybody that's tied to that switch is going to get that broadcast message. Okay? Everybody responds back to that message. True or false?
False.
False, right? So everybody's on the lookout for what? Everybody's going to ignore it unless you're the matching IP address. If you're the matching IP address, you're going to say what? There I am. Oh, you want my MAC address? Here you go. And I'm going to send it back. Now, when you send it back, the roles change. Okay, the sender and the target is now those roles swapped. Okay, so we come back. I want you guys to see that you have an opcode 2 reply, and now for the ARP packet, what do you have for the ARP portion? What do you have for the destination and MAC addresses? Destination. You have legitimate ones on that one, right? Okay, and also if you look up in the Ethernet part, those will match. Okay, all that matches. Once you do that, guess what happens when it gets back to the pinging computer? It puts it where? It puts it in its ARP cache. Now it says, all right, now that I have that, now I have the ICMP portion that always stays the same. I always had the sender and the receiver IP address, but now that missing piece, I have the MAC address for the destination. I can now form my ICMP and send that out. Okay, that is the level of detail. I don't care about the command line ping. Who cares, okay? That means nothing. Like, all right, you guys started out. But what I just described, I want to see explained in the gobbledygook of the packets in the belly of the beast, okay? So if I did that and cleared my ARP cache in part 2, what else do I need? So for me to go look at my ARP cache, I need a. So when you go look at the ARP cache, you're looking up a MAC address based on the IP address. But if you just ping by name, oh my gosh, that's not an IP address.
Use a subnet, some kind of name.
Some kind of name resolution. There's like you'll see DNS, LNR, or NetBIOS. Okay.
And that'll, because it'll know based on if it's a legit computer name, it will send you back what.
It'll send you back the IP address, and then now I could lather, rinse, repeat what you just did in part 1. Okay. Part 3, we're pinging from a virtual machine out onto some computer on the host network. Okay. If I'm going outside of my network, what's the last thing I see going out? The gateway, right? Okay. The last thing, just like going in and out of your backyard, you go in and out of your backyard to the gate. So the last thing you're going to see going out is your gateway. So the IP address is going to be the IP address of where you're going. What's the destination MAC going to be? Is it going to be the MAC address of the computer on the other network? No, it's going to be the destination. It's going to MAC the address of the gateway. That's the last thing you see on the way out. Okay, when a reply comes back in, what's going to be the source? It's going to be the gateway because that's the first thing I can see. Carlos is all over it. Carlos is all, he's got it, right? Yalta's rubbing off on him. Okay. Yeah, exactly.
He's whispering.
So does that make sense, guys? That's the level of detail. That's what I want to see. That's what I want to see in this lab. So take the Wireshark and open those up, and I want to see like I don't care about the ICMP part. That's always the same every time you ping. What I want to see is the IP addresses and the MAC addresses for those layers. Okay. Does that kind of make sense? Sort of, kind of. Okay. So what I've done is I've extended out lab 2 to Friday at midnight. So beyond that, I had to start taking late points. So we've been kind of like kicking this. You know, like you go to graduation, that ball's floating up in the air. I feel like that ball's been up in the air forever. We got to bring it down and move on. Okay. So we've got to move on from lab 2. So lab 3 is not too bad, but lab 3 is going to be kind of the same documentation. I want to see this time that you have like an IP address and the MAC address is just going to be the EPIPA. So in this one, you're not going to see a gateway. Okay, on the EPIPA, you're not going to see a gateway. So what does that mean? Can I go outside this network? No. No, right? So EPIPA is limited to just your network. Okay. Questions, thoughts? Does that kind of make sense? Everybody feel grounded now? We're all good? Right. So I'm going to give David and Darren a second. So I know some people are probably thinking, gosh, this is a pain to go to that level of detail, but I'm telling you, you will have to go to that level of detail when you're troubleshooting. When you get outside here and you're at a job site, you're not going to have me groaning on to tell you guys how to do this. So you'll have to, once you get those basics down, it's just so fundamental. It'll be like, oh yeah, I know how to do this. It was lab 2, that lab from hell.
The never-ending lab.
The never-ending lab. All right, cool. So is anybody not ready to move on? Anybody have any questions, thoughts? All right, so we're one person away from perfect attendance too. So Mike Roberts, Flash. Yeah, so we have everybody but Flash here. So let's see, we have Mohammed, we have Meher. Yeah. All right. So hopefully he'll show up. So what I wanted to do today is start looking at chapter 5, and there's all kind of various things in this chapter. Really really kind of, this kind of sets the tone. I mean, this is probably one of the most important chapters of this whole book is chapter 5. So what I want to do is go through this worksheet today. So if you go into Net Plus PowerPoints and Quizzes, there's by chapter 5, there should be a chapter 5 in-class worksheet. And what I want to do is go through this. So at the end of the day, our machines can only understand what kind of numbers?
Binary.
Binary, right? All those IP addresses we've been putting down have not been binary. They've been what? They've been all octets, like 0 to 255. Those have all been like base 10 decimals. So what to do? How do we convert? What does our computer do behind the scenes? Well, everything's kind of based on these octets. It's all based on powers of 2. If we take 2 to the 0, that's going to be 1. 2 to the 1 is 2. Let me start drawing here. Let's see. View and do page width. All right, so we see right here, hopefully my pen works. Pens, red. All right, so we see right here we have like 2 to the 0, and that's 1. 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8. Has anybody not worked with powers before? Is this any leap of faith for anybody? Hopefully this isn't too bad. Okay, so this is the least significant bits, and this is the most significant bits. Okay, and this is just like, we go from 0 to 7, which is what? 8 different things. So that's why they're 8 bits or an octet. That's why we call them octets. It's 8 bits, just like an octopus. So the way we do this, if you're going to go from binary to decimal, is in this case, let's say you have 1, 0, 0, 1, 0, 1, 1, 1. How do we convert that to decimal?
So you just add all the ones to the one.
Yeah, so where the one's at, so we take 128, you just take this number times this number, and then you add it all up. So in this case, we're going to take 128 times 1, 64 times 0, 32, 0, 16 times 1 is 16. Here's some zeros, here's some ones. So then we're going to add up 128, 16, 4, and 2, and we're going to get, what are we going to get there? So 150, right? So this comes out to 150. Okay? So what I want the class to do then is take this number, 0, 0, 1, 0, 1, 0, 1, 1, and convert that to decimal. And you can work with each other if you want to. So once you get the answer, check it with your buddy. Flashes here, stickers for all. Keep the faith. Keep the faith. All right. Man, you guys are burning through the stickers here though. This semester. I'm dying here. All right. Here you go. There we get a sticker for your name card. You get the whole thing, Mike Sabo. You're so beloved for showing up. You get the whole sheet. No, wait. Give us IT. Everybody gets a sticker. Everybody gets a sticker. What I want. All right. And just send them around and back if you're around that way. Either way. One sticker.
One page.
One sticker, one sticker only. So once you get 10, you just start doing stars on there. It doesn't matter beyond 10. You get your 1 point of extra credit for the course.
Okay.
Yeah. So good, awesome, perfect attendance. Speaking of perfect attendance and showing up on time, I'm actually getting observed on Monday by a peer for my tenure. So if everybody could show up, one, great, awesome. And if you guys could be on time, even more better. So that would be much appreciated. Okay. I'm sorry? I'll give you, no, well, not, no, I'll give you guys one sticker. So if everybody's here.
Two if everybody's on time.
Yeah,
Great
that's
motivator.
you guys should want to come across.
That's too easy.
This is like, this class is fun. You guys just like play games and do labs and wire and do stuff. Should be getting paid extra. All right. And speaking of Monday, we're going to be going over Lab 4 work groups. Okay, so we're going to start looking at work groups. So there's 2 videos on the Lab 4. There's this guy, Eli, the computer guy. He's really good. So my recommendation is go watch those 2 videos. It'll really help you out on Monday. Okay, so now we have independent machines. We're going to start having them talk to each other through work groups. And we're going to find out this is good, but somewhat painful to manage. And we'll get to this thing called a domain. Okay, domain controllers in a couple more weeks.
Lab 4, you said.
Lab 4, yep. Lab 4, and you'll see the links in the lab. The links are actually in the lab.
Okay.
So if you go in the Lab 4, you'll see the links down there, and those will take you to Eli, the computer guy.
That's in Blackboard, correct?
In Blackboard, yep. So Lab 4 and Blackboard. All right, so who came up with this number? What did you guys come up with? 43. Anybody come up with anything different? Everybody came up with 43, hopefully. Okay, so that's 43, awesomeness. Okay, so 43, and how did we do that? We had 0, 0, then we had 32 plus what?
0.
Plus 0 plus 8 plus 2 plus 1, and we got 43. Okay, good. Does anybody not see how to get that? Everybody got that, okay? So we went that way, but let's now be a computer and go from taking an IP address, octet, and making that into ones, because we said our computer, even though we put things in like numbers and decimals, our computer can't understand that, but it's just for us as humans. So let's look and see how we do that. So for us to convert from decimal to binary, so let's say we wanted to take 167 and convert that into decimal. The way we do that is you look at the number, and if it's greater than or equal to the numbers up here, starting with 128 and going down to 1, then you put a 1 in there. Otherwise, you put a 0 and move on. So for this one, is 67 greater than 128? True or false?
True.
True, right? So we put a 1 there. Okay, so in the 128 column, we put a 1. Is 39 greater than 64? No, you put a 0 in there. Okay, is 39 greater than 32? Yep, so we have 1. So when you do that, when you put a 1, you actually take the number and you subtract it by this number to get the resultant. So we start with 167. Since it's greater than, we put a 1, and then we subtract. And then now we're left with 39. So we had a 0, and then now we have what? We had 39 is greater than 32. That's true. Then the next thing we do is what? Subtract 32 from that, and now we're left with 7. So is 7 greater than 16? No. Okay. So is 7 greater than 8? Okay. So you have another 0. Is 7 greater than 4? True or false? True. 1, 0, 1, 0, 0, 1 now. Okay. So we subtract that out. We have 3. Is this 3 greater than 2? Yes. 1, 1. And then we have 1 greater than or equal to 1. Yes. Okay. So that would be our number. Going from decimal to binary. Okay. Anybody? Brian.
How come you don't subtract 39 from 62 and it's still 39 from the third column?
For which one, Brian?
It goes 167, and then you subtract 128 from that, and then it goes 39.
Because 39 was not greater than that, you put a 0. Anytime you put a 0, you don't subtract. You only subtract when you do the ones. Okay, everybody hear Brian's question? Good question. Only when you put a 1 when it's greater or equal to do you subtract. Okay? All right. So let's do this. Convert 249 to binary. Convert 249 to binary. Okay, and there's the numbers you're going to use, 128, 64, 32. Okay? So the first thing you do is what? Is 249 greater than or equal to 128? Okay, 1. And then you do what? You subtract that, so you're going to be left with what? 121 greater than or equal to 64. I'll let you guys do the rest. Okay, so yes, that means you put a 1 in there and subtract 64 from that, and you keep chumming through. Okay? All right, so is anybody still working on this? Everybody's got it? Looks like we still have some people working it. It's fine. Because we start off with 249, and because 128 was greater than that, we subtract 128 from there. No, 249, sorry. 249. Yep, so just like kind of like looking at greater and equal to and then subtracting it out. Okay, so how's everybody doing? So check with your neighbor and see if your neighbor agrees with your number. Okay. Is everybody getting what your neighbor got? Hopefully.
A lot. If there's lots.
Yeah, I should just.
Okay, so let's go through this as a class really quick. So we have 129. Was that greater than or equal to 128? True or false? True. Okay, so we put down a 1, then we subtracted 128 from 249. Then we came down with 121. Is 121 greater than or equal to 64? Okay, so now we put a second 1 in there, and we're going to subtract that from there, and we get what? 57? So we have 57 is greater than or equal to 32. True or false?
True.
True, right? Okay, so now we're left with what? 25? Is 25 greater than or equal to 16? True. Okay? Then we subtract 16 from 25, we're left with what? 9. Is 9 greater than or equal to 8? So we have 5 ones in here. We subtract 8 from 9, and we're left with what? 1. 1 greater than or equal to 4. 1, 1, 1, 1, 1. Actually, it's sloppy. So we have 1, 2, 3, 4, 5 ones and a 0. Okay, and then we say, is 1 greater than or equal to 2? No, so we had another 0 in there. Is 1 greater than or equal to 1?
No.
Okay, so we're left with what?
We're left with 1, 1.
So you should have 5 ones, a 0, and a 1. Okay, you guys get that? Good. All right, cool. So Anybody want to go through any more? You guys kind of feel like you have everybody kind of gets that for the most part, hopefully? Sort of, kind of?
Yes.
All right, cool. All right, so let's talk about subnetting. Let's talk about subnetting. And now your brains are going to just fry. Your brains will fry right now. Okay? So does anybody remember, if I see a 192 address, what address, what class of address is that? Class C, right? Because we said anything that starts at 192 that goes up to, I think, 224 is going to be a Class C network. Okay? Class C networks always have, by default, the subnet mask of 255, 255, 255, 0. Okay? Another way to shortcut that is to write /24. Okay? So let's take a look at what this looks like. So if we have like 192, so convert all these numbers out right here. So 192 is going to be what? So do this really quick. So convert 192 into decimal or to binary. 192 to binary. Or somebody just give me the numbers on your calculator. So you guys should have a decimal to binary thing. Yep. It should be like 1, 1, I think all zeros. 128 and 64, yeah. So I'll help you guys out. Okay. Then 6 zeros. Okay, then 168 is going to be what? It's going to be a 1. Then what? So it should be 1, 2, 101 something, 101, because we have 32. So 128 and 32 is 160. And then we have that. All right, cool. All right, so good. All right, and then we have 10. And 10 is going to be what? That's going to be 4 zeros. And then 1, 0, 1, 0. Okay, and then 0 is going to be what? All zeros. Okay? But the key about this is looking at the subnet mask. 255 is what? In binary, 255 is what?
All ones.
All ones. Okay? So here's the IP. Then here's the subnet mask. So anywhere there's a 1 down here, that is going to be all part of your network. Your network. So we have 255, 255, and 255. So the only thing that comes, so then this part is going to be the network part. And then this last octet is going to be the host. We start with 0, we can go up to what? 0 to 255, right? Okay, so 0 to 255. So 0 is always going to be what defines your network. Defines. So you can't use this one. And then 255 is always going to be your broadcast. You can't use broadcast. You can't use that one either. So how many available hosts do you have now? We took 254, right? So 0 to 255 is actually 256 possible combinations. And we took out where we defined the network and the broadcast and took that out. So you can now have on this one from 1 to 254. Okay? These are available hosts that you can have because we have the network part and the host part. So if you go do any, so what about if you went to 192.168.11.2? Can you do that? Is that in your network? 192 is 192.168.11 in your network? No, right? It's not in your network. So for me to go from that, so if I went to 192.168.11.5, I'd have to do what? I need a router. Okay, everybody hear Mike?
Mike. Hey, I mean.
Mike's here.
Mike's here.
Mike's here. Wow, it like pays like do this in the Marine Corps for several years and be a Network Plus certified, right? It's like Mike knows a thing or two. Mike knows a thing or two here.
Can we go back up a little bit, Professor?
We
Why
can.
can't it be 11? You said 11. It can't be.
Because that's outside of this network. So anything, so this network is going to be, so hosts on this network are going to be 192.168.10.1 to 254.
Okay.
Anything outside of 192.168.10.1.0 to 255, you know we can't use those. So essentially .1 to 254 is a different network. Okay? So if we have a, so now let's play this to lab 2 now. Let's play this into lab 2. So now if I'm going to go from a network to a network, on that network you can have one switch. If I'm going to go network to network, I need what? A router. So I need to do something routing. So a lot of times today's switches incorporate layer 2 and layer 3, so you don't have to have a separate router, so it can route from layer 2 to layer 3. So we call those routing switches. Okay, those are called routing switches. Okay. But so if we did this, and if we're going to go bringing lab 2 into play, if we're going to go outside of this, and let's say our gateway is .1 here. Let's say .1 is our gateway. Then any packet going out of this network would look like what? If I did an ARP or if I did a ping or something like that, the MAC address leaving this network would be what? Would be reachable. It'd be 192.168.10.1. So that would be the IP address, and whatever the MAC address is of that gateway device, it's going to be that MAC address. So as it goes out, its destination is going to be that MAC address that corresponds to that IP, and then the source on the way back in is going to be the MAC address corresponding to that IP. Okay? Okay? So that's the level you guys need to know this. Okay, that's the level you guys, and it'll take a while, but it'll start sinking in. All right? So let's go back to our question then. You're a junior network engineer at your company. The senior engineer provides you with the following network address: 192.168.10.1 or .0/250 or /24. She asks you to subnet the network into 6 subnets. So we want to take this one block of network we have and split that out into 6 other networks. Can we do that? Huh? What? How? Tell me how. That's pretty cool. So how do we do that? How do we do that? Not NAT. Not NAT. So if we look at this, so if we look at our subnet, we have 8 ones, 8 ones, 8 ones, and then a bunch of zeros here and here.
This is the subnet?
This is the subnet.
Okay.
So the subnet mask 255, 255, 255, 0. Okay? What we can do is we can borrow host bits and convert them, these zeros, into network pieces. Okay? When we do that, we start limiting the number of hosts we can have on a network, though. Okay? So that's kind of cool here. So if we borrow 1 bit, then we can have 2. So if we borrow this, make this a 1, 2 to the 1 is what? 2 to the 1 is 2, so now we can have 2 networks. If we borrow another one, we can have what? 2 to the 2 is 4, and we need 6. Can we stop at 2? So is 6 greater or equal to 4? 6 is greater, so we have to borrow 1 more. Okay, so we have to borrow 1 more to get up to 8. Okay, does everybody see that? So the requirements required us to have 6 subnets. Okay, I can't get there with 4, so sometimes you have to exceed. You might have to exceed the 6 and do 8, because you can't say 2 to the 2.5 power. You can only do them in whole increments. Okay. They don't add together. Okay. So you have to do. So you either have to meet or exceed. So that means you have to do one. You have to borrow 1 more bit here, and 2 to the 3 is going to be what? Not 6. 2 to the 3. Everything doubles, right? Okay. So that means I'm going to have 8 subnets now. I have 8 subnets. So now we're expanding this out. So we're going to subnet this guy. So these zeros are now going to become 1s. So now how many bits do I have for my hosts? Actually, 5, missed the 0. We have 5, right? Okay. So what is 2 to the 5?
32.
32. Okay. We used to have how many? Before we had how many possible hosts? We said 256 minus the broadcast minus the definition. So we had a possible 254. If we only have 32 possible hosts now, guess what? Every network is defined by, what it's going to be defined by and a broadcast. Therefore, in each one of these networks, we have a total of how many hosts now? 32 minus 32 minus 2, so we can only have now 30 hosts per network, per subnet. Okay? This starts getting deep. Your head, at this point in time, your head should be hurting. Okay, so everybody hear Brian's question? Why did I have 32 and get to 2? Remember that you always have to have an IP that defines the network, and that's a broadcast. So you're always going to be whatever your subnet or network's going to be. It's always going to be -2. You always have to define it, and you always have to have the broadcast. Okay. You always have to define it. You always have to get the broadcast. Okay. All right, so everybody do a quick hand stand break, so I'm sure your brains are spinning by now.
I saw it yesterday. Yeah, makes sense now too.
Cool.
Going over other stuff.
So how long did you do networking in the Marines? Like 8 years, 7 years? Yeah, so like that. So I'm gonna make Mike my tutor. She's gonna be my deputy. Here.
She's got to wear the
Yeah.
badge.
Yeah, give me that too. Like, oh crap.
And the king. See what happens when you miss a day? I would love to wear the badge. I'd make it a bandana.
You swear you deputized today to help out. There you go. All right, everybody can sit down.
All right.
All right, so let's draw this out, and I think it's going to make more sense. I think if we draw this out, it should hopefully make more sense. Here's my magic pen. Uh-oh, there's a magic pen. All right, so let's write this out, and this will probably make more sense. So we're saying instead of now of one network that has up to what? We said one network, our original subnet was 255.255.255.0. Another way to write that is you could say /24, because how many 255 is how many zeros or how many ones? 8 ones. If I do that times 3, Oh my gosh, there's that 24. Okay, so there's the 20. There's where that 24 comes from. Okay, so what you essentially did is you converted a /24 network. Now, if you borrowed 2 bits, 24 plus 3 is going to be what? So now you've just basically created 8 27 networks. So you used to have one network based on /24. If we borrowed 3 bits, if we do 24 plus 3, that gives us what? 27, right? So instead of having one network that's /24, you now have 8 networks that are /27.
Why? What? Yeah. What does it multiply so much from 124 to 8?
I'm sorry?
Why 8 networks?
Why 8 networks? Because remember we borrowed the bits up here, so we had all these zeros that were host bits, and we borrowed them. So we borrowed these 3 bits right here. Therefore, that 27 plus these guys now became 20. The 24 plus those 3 now become what? Become 27, right? So let's look at this. So this is once here. I'll show you guys the magical thing right here. So I'm going to go down here, and we're going to come up with a new sheet right here. So let's draw all these guys. Well, let me insert a new sheet. Insert blank page.
Blank page. MLS formatting. Double space.
Where did it go to? Put it up here. All right, put it up here at the top. All right, so before we had what? Let me go into pens. Okay, so we start off with 192.168.10. And we said this network is defined by what? This network starts at .0 and goes to what?
24. Or no, 254.
255. 10.255. But we know that we know that 192.168.10.0 was defined our network. And we know that 192.168.10.255 was our broadcast. Okay. So then how many hosts did that leave us? 256 minus 2. We always subtract 2 because we always have to define it. We always have to do a broadcast. Okay? So when we split this up into 8 networks, guess what we do? I'm going to switch colors here. 192.168.10.0 to what? Not 254. 192.168.10.31. That's our first subnet now. Okay? Guess what our next subnet is? 192.168.10.32. And that's going to go to what? 63. Because you can have 32, you have 30. Because if you take, okay, if we take 256, so we said we had 256 possible things, right? What happens if we divide that by 8? We get what? 3, 24, 16, 32. So now each one of our networks are 32 for the host because we have 3 bits that we borrowed that are now /27, and we have 5 zeros. 2 to the 5 is 32 for each one of our subnets.
You say so.
Okay? So this is like subnet 1. This is subnet 1. sub 1, this is sub 2, okay? And then if we look at this, guess how many hosts we're going to have on this? If we have 32 possible, we can only use how many? 30, right? Okay, because 192.168.10.0 is going to define, and then 192.168.10.31 is going to be the broadcast. So that leaves us what? From 1 to 30 to be legitimate hosts that we can have in here. Okay? And each one of those are now like its own separate network. So each one of those is going to have like a gateway. So when you start subnetting, the only thing is when we subnet, you come at the cost of reducing your hosts. Because in actuality, we started with one subnet that we had how many possible hosts? 254 possible hosts. And now for each one of these subnets, we have how many possible hosts? 32 minus 2, 30 times 8 is what? 240. Okay, so we lost 14 hosts in here due to the overhead of creating each of the subnets. I know it's tough, guys. Trust me. I was once on that side before. I was on that side before too.
And you kind of lose one for the default gateway too with each network.
And you lose one for the default gateway too. Yeah. But we won't go there. We'll just stay with here. Okay. I am recording it. All right. So what do you guys think is subnet 3? Let's do subnet 3. 192.168.10.64, and we're going to add what? 31 to that. 31. So it's going to be what? 95. 95. Okay. And guess where subnet 4 is going to start at? 192.168.10.96. And you're going to add 31 to that. You're going to get what? 127. Okay. Wow, look at that. 0 to 127. That's split in half. You expect the next one to be 128. Oh my gosh, 2 to 8 is 128. You guys will have dreams and nightmares about these numbers. Okay.
Just nightmares.
All right. So then what's the next one going to be? Subnet 5.
10.128.
It's going to be 192.168.10.128. We're going to add 31 to that. We're going to get what? 159. Okay. And then we're going to start at 160. And we're going to get a what?
191.
191. And we're going to start at 192. And we're going to go to 23. 223. Okay. Then we're going to do what?
224 plus
224 plus 21, 31. Oh my gosh, look at that. We got the 255. Hot darn. Look at us, guys. Hot darn. Those are the 8 subnets now. Those are the 8 subnets.
So it's okay if you do equal or greater than the rest.
You can take a picture of that. Yep, you can take a picture. It's all on recording, but you can take a picture of that. Okay. Now remember, those are the total possible, or I shouldn't say, that's all the IP addresses in there, but you always have to subtract out how many? 2. 1 to define it and 1 for the broadcast. Okay? So this is always going to be right here what defines. This is going to be the defining. So 0, 32, 64, 96, 128. All these guys are going to be what defines your network. Okay? And guess what all these guys are over here? Broadcast.
So basically between 1 and 30.
All right, did everybody hear Jake? Say that again, Jake.
So if we have a define and also the broadcast, so in between those, it's always 30 that we can use.
So for this one, right? So the usable IP addresses on this subnet 1 is what? 1 to 30. What's the usable IPs on this one? 33 to 62. Okay. What about this one? 65 to 94. Okay. What about this one? 97 to 126. Okay. And if you count those out, guess how many you're going to do? You run out of fingers and toes. You'll have to borrow your friends, but you're going to come up with what? 30. 30.
This is
Because we used up one to define it and one for the broadcast.
no, this on the side.
And then later on, you lose another one.
And you'll lose another one due to the gateway.
Later on.
Yeah. So what happens is a lot of times you'll get these networks, and you'll start chunking these out on VLANs. Oh my gosh, here's a word, virtual LANs. So in this classroom, we have row 0, we have row 1, row 2, row 3, row 4, and row 5 are those bullet tables. And they're also attached to the 2 computers that are over at the library. So if you want to communicate from this row to this row, guess what you have to do? You have to use a router, but we have layer 3 switches, so you can route through the switches, but you have to set up the route in the switch. Let's say going here to here, go route that, okay? That'll lead to things like spanning tree protocol and all kinds of other things. Gobbledygook.
Now, if we did this with only needed 4 subnets, those numbers would have changed.
Okay, so everybody hear David's question? So if we needed, so what about, let's go do this, and let's say we only needed, the network engineer said, all right, I changed my mind, you only need 4. How does that change our picture?
We only need the first.
Okay, so how would that change everything? So we'd have how many borrowed bits now? 2, right? So instead of /27, it'd be a /26, right? /26. So then what's 256 divided by 4? 64. Okay, so you'd have 64 per network, per subnet. Okay, we have 64 per subnet, but how many usable would you have? 62, because we have what? The defining and the broadcast. So what would that look like if we did this? Let's do it really quick. This will help you guys out. 192.168.10.0 to what? 63. Okay, what would this next one be? 64 to 127. Okay, 128 to what? 191. Okay, and then 192 to what? 255. Oh my gosh, we always get back. We always start with the 0. We always get back to 255.
So if you don't get 255, then something's wrong.
Something's probably awry. Something is probably awry. Chris. Okay, so the 256 is what? What's 2 to the 8? So how many bits do we have? We had how many bits? We had 8 bits, right? And if I take 2 to the 8, that's 256.
You're just creating a network out of bits.
Right, so what happens is on these, when we start subnetting, remember we had how many zeros on this problem? We had what? On both of these, we start off with what? All ones for the first 3 octets. And the last one was zeros. So when you subnet, you're borrowing and converting these zeros into ones. So that allows you to set up separate networks, okay? But it takes away from your number of hosts.
What happens? Oh, so
Right. So essentially, this /24 in the first case, we borrowed 3 bits. So the /24 became a what? /27 Okay. And then on that second example, we said we borrowed 2, so the /24 would become what? /26. Okay. So here you had 3 borrowed bits for the network, and you had 5 bits for the hosts. That's why you had 32 minus 0, or 32 minus 2. That gave you 30 possible hosts. Okay. Over here, you borrowed 2, and that left you how many? Because this always has to add up to 8 in this particular case, because we start off with 24. So we have 32 possible bits, and we start with 24. Okay, so 32 minus 24 is 8. So this combination always has to be 8 when you add those together. So this one, we split it. We borrowed 2 bits, so that gave us 6 host bits. So we have what? We have 64 now per network, minus the 2 for the defining and the broadcast. So let's see what 62. All right, so let's do this. Let's take a short break. Just a short break. So 12:10, we'll start back up. 12:10. So I want you guys to cool down, your brains to cool down a bit here. We've been working them hard. I'm recording. All right. So what questions do you guys have? And you'll scare me if there's no questions. I am expecting questions here. Delta.
In reality, does anybody actually break things out into subnets that aren't classful? Does it actually work the other way?
Yeah. No, at SCAC I ran a lab. At SCAC I ran a lab, and it was around the whole United States, and we had we had a /22 network, so we had to subdivide it out. Or no, we had a /24. So we had different projects. So when I was there, I'd always like subdivide it out to different projects, because we had some research and development, some stuff that customers can get to, some things you couldn't. So we use it for a lot of security. So you actually will do this. Yeah, so you actually will apply and use this. More importantly, you'll do this. My first question on the test was, you're provided this network, you need to have, I think it was like the same thing, you need to have 6 subnets. You had to know in your head, all right, I need to create 8, what's all the things, and go configure the switch or the router.
Can you subnet a subnet or no?
You can. Yeah, it starts getting kind of messy, but yeah. Right. So let's go. Let's see. Let's go down.
Subnettion, whatever that. That's scary.
All right. So let's do another one. Let's do another one. Let's do a. So I want you guys to work with each other on this one, and let's change the problem around a little bit. So let's say you guys have a let's say that you have a 192. I won't even get evil. I won't even go into class B. So remember, this is just a class C network. What about if this was like a 10? Well, actually, we'll get evil for a second.
This one is only like 10.
Okay, so if we do 10 down here, this is a what? 10.1.2.3. You know this is automatically, because it started with a 10, it's a class A. So what's its subnet mask? 255. So we could say 10.0.0.0/8. Okay. So the 10 is the network part. So what's the host part?
0001.
Okay, so that's what? What is 2 to the 24? That's how many hosts you can have on this network.
Oh, 254?
2 raised to the 24 power. So I forgot, it's like 18 billion or something. So let's see, let's take a look real quick. So I'll do it on the calculator. Okay, we're going to do a calculator. We're going to go into scientific view.
big number.
So we're gonna go 2y24.
16, 1, 7.
Okay, yeah, there we go. So we're gonna copy. Okay, and then we're just gonna paste this right here.
Well, it's 214 because you need to.
So it's 16.
Million, 777,000.
Mm-hmm.
That's possible.
Mm-hmm. That's how many possible hosts. So what do you think? One network or possibly a couple in that one? Couple networks. Okay. So I want everybody now to do ipconfig, on your host machine. On your host machine. ipconfig on your host machine. Now it's going to start all coming together here. ipconfig, what do you guys come up with? 10 what?
131.
Okay, everybody's is going to be different, right? What's your sub? So dot subnet mask.
255.
Oh, so what do we do as a school? What do we do as a school? If we have a 10 address, that's a what?
Class A.
Class A. So what did we just do there? Oh, so we what? We borrowed how many bits?
16.
16. Oh my gosh. So we subnetted this out. Look at us. Oh my gosh. Now we start to see right there, Yalta. You know, as a school, we subnetted this. Okay. So we have 1010. So we had to borrow what? So this is 255. We had 8 ones here. And then 8 times 0, 8 times 0 dot 8 times 0. We did what? We borrowed 16. Okay, and now we have 8 zeros for what? Host. Good. Rock on. Okay, everybody hear David? So we started off, because it's a 10, we automatically know it's a Class A network because of our subnet mask, and that would be listed as what? We could write this network as what? 10.10. What? 131.0. That's going to be defining our network. 24/24. Okay, you guys see that? So now you guys are starting to see it. So even though it's an A, we start off with 8, 255, 255. That's how many ones? 24, right? Because each 255 is 8. If you had 3 255s, add up 8 plus 8 plus 8, /24. Okay? So if we look, I'm willing to bet, without even looking here, typically your gateway is going to be the first available IP address after you define the name. I suspect if you guys looked hard at your IP config, you might see 10.10.131.1 in there. Anybody see that? There you go. So there you go. So typically your gateway is the one after. So guess what you guys have at home now on your networks at home? Anybody seen something like 192.168 at home? .1 or .whatever, and your subnet mask is what? 255, 255, 255.0. So now you should start seeing, oh my gosh, I've been seeing this for years, but now you're like, oh, this is what it means. This is what it means. There's something special about 192.168. Does anybody know? Is it a public or privately routed network? Private. So guess what? So if you're on the internet out here, you cannot route directly to 192.168. It's private, and your gateway at home, gateway device, is acting as a router. It's routing your one IP address to all your backend stuff through something called network address translation that we'll get to. That's how you can share one IP address across all your devices. You don't pay Cox Cable 15 connections. That's like 50 times 15, like $750 a month for each address. You share that amongst the one IP address coming in through NAT.
There's different types of NATs, right?
There's NAT and there's PAT, so we'll cover both. NAT and PAT. NAT and PAT. NAT and PAT. All right. So let's do this. Let's say you're MiraCosta. You're MiraCosta, and you want to create. Actually, no. I won't do that to you guys. So let's do the 192 again. So let's start off with the 192.168. Let's say .20. That should be near and dear to you guys. 192.168.20. What's that? Have you guys seen that one before? What's that one belong to?
The VMware.
VMware on these machines, right? There you go. So we know that that's .0 will define, because we look at that, it's a /24 network. And it has what? So we know that 20.0 defines. Okay. On VMware, 20.1, the .1 is always going to be the host IP. .2 is what? The next available one is going to be the gateway. And then you're also going to see 254, and that is your DHCP. And then .255 is your broadcast. Okay. So what I want you guys to do is to create 4 subnets. Create 4, so you're going to buddy up with somebody, or just work it in 3. So you just work 3s, 3s, 3s. And then, Sheriff, I'm going to have you work with Chris and Flash in the back. So then I want everybody to subnet this out. Subnet. So we got to give you your Sheriff sticker for the day, too. So you're getting all kind of stickers today, Mike. All you need to do is just show up, right? So you show up and you take all my stickers. I almost got to shoot today. So subnet this out to 4 networks. To 4 networks. Subnet out to 4 subnets, I should say. Subnet to 4 subnets. Okay. And then for each subnet, provide define a network, find IP, broadcast IP, and then the host ranges for each of those guys, host range. Okay, so do that. So do that amongst your rows, like so U3, 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 4. Okay. And then Mike, you're working with Chris and Flash in the back. And then tell me how many borrowed bits. I also want to know how many borrowed bits. So borrowed bits, start off with that, and that'll get you guys started. Borrowed bits. Yeah, so come up with, tell me how many borrowed bits you have, and then you're creating 4 different networks, and you're going to say the range with the points each one to broadcast to the greater subnet. Yeah, that's what we did last time.
One word.
And here.
So, this is our return that we got, right?
That's the network you were providing. You have to subnet it out to 4 different networks.
Yeah, so this is going to be 28.
You probably went. Well, yeah. So remember, each one of these is the power of 2 right there. So how many do you need? So if you did 1 borrowed bit, that's 2 to the 1. That's 2. And if you did 2 borrowed bits, it's 2 to the 2, and that's 4. So you only need 2 borrowed bits. Yeah.
2 bits.
Yeah. Because on that one you borrowed 4. You borrowed 4, so you actually have 16 subnets. If you did that, each one has 16.
Why do I divide that 4?
Because that will give you the amount. That'll give you the full possible IPs for each subnet.
So if I
Exactly. Right. So the first thing to do is just go 0 to 63, 64 to 127, 128 to 95, 96 to 92. Yeah, so remember, all right, so everybody listen up for a second. This is what will trip people up. When you guys start counting, you normally start counting at 1. When we start counting in this class, we count at 0. So that does count as 1. So 0 to 63 is actually 64. That's why. So you're starting off with 0. So that counts. Zeros count. All right, how you doing, man? Guys, did you read? Read a chapter? Did you watch it? No, you got to. You got to class. I mean, if you go into the Blackboard or like I have /26. And that's how you do it. So I originally had there's all the right, but I'm not counting video yet. So if I divide that by 4, each of these networks is going to have 64 values. Right? So that means that I'm going to have this network is going to be
We need to borrow 4, right?
And my next network is going to be 64/6. That network,
That's 64, right?
All right, how's everybody doing? You guys have it?
Minus 2.
How you guys doing? How you doing, Hunter?
For some
Yeah, so these are all going to be your clients, and then yes, range, usable,
So more of it. Yeah, so there's two, yeah, then there's 63 4, some more 6, right?
And then keep it wide at 0, it will be your broadcast. And you use it like you
Mine is mine.
All right, how you guys doing?
And there's broadcast, right?
How do you start? Right. So you start off at 192.168.20.0/24. So we need a subnet out
So for that, our IP address,
I guess it's borrowing.
24, so like 24. We got 26. So this becomes 26.
Look at it. The first time we borrow, we need a set. 2 quarters, and we only need 4, so we need 4. Right.
If you ever do programming,
we'll start to take that 4 and divide it into 2. So it's usually what it gives us. Honestly, if I were that range,
so we use
help.
Because
Right.
you count 0. You start counting 0, 1, 2, 3. 1, 2, 3, 4,
So,
because we always have to count 0. 0 to the it's standard function. 0 to the value.
not hopeless.
So we need to say your prefix is 20. So what it means, like 24, right? So the first octet is 8, plus the second octet is 16. The third octet is 4, because we have value. Now, because we added 2 by so 24 plus 2. Now, with the value of that, you need
That part's
really
really
4 bits.
Second part. They wanted to use it.
So,
Just go over
subnet is 2. Second subnet, the second one is so you add these 2, but basically we always have comes to here you go. So number beta is always 2.
what is I guess when I say that, because 0 plus 54 is 64. So if you're thinking about it like this, the important thing to understand is that you're at number 4, right? It's not valid.
Create subnet.
But I guess when you're figuring out that first of all, it's like so in this case, 64 is acting
we borrow two and we need to create all subnets, so it's 6, right?
Yeah.
So, you can work with whatever you select, what's that up your file. Now it's
Because
first one.
oh, because the binary base 2 number hits. That's where it's like. So for all these two raised to like
Oh, yeah, yeah.
64 is 2.
Okay, well, wait, so you get some good. Where you get oh, that's counted. Just counted. Okay.
Divide by 256. That's your range. We did it.
It just so happens like that each of these two things, if you divide them into 6, you always get a range.
Your implementation one time is basically. I understand why that makes sense. Like you started from 0 to it's like you're moving between
My lab 3 looks a lot better than my lab 2 did.
So we had our address, our network. It is a class C. Yeah, it's a class C. 192.
All right, how you guys doing? So they have Oculus Rift next door. Anybody seen an Oculus Rift before? Yeah, well, that's craziness. Wow, it's almost like nauseous. All right, so how you guys doing? How are we doing here?
So is it going to be like
So what's your broadcast? So how many available services do you have? What's your broadcast?
yeah,
What's the available
so if you want to force
The point of this is that I'll note this. I actually see that. In class A, which was
Right, so, well, so this
we're subnetting that out.
has to be right. So available, one,
I'm at 10, 6, and about whatever is like
yeah, there you go. There you go.
It's going to be this one's 2 to 1, 2 to 2.
Yeah, because the available code,
2 to 2. 2 to 2 is I want to make sure.
Right, how you guys doing? You getting there now?
You take how many possible networks are 0 to just subnet.
Okay, so, well, just, if you look at this, it's like, so you have like 0. So how many 4? Never. You start off with 4. You have 24. Okay, that's your initial one. So you have how many?
0. Drop 68 free. Because 0 counts.
That's where I'm going. This is 63.
My subnet, which shows me
That's where
You guys have to take down.
So, right. If you added, you're only at maybe at 68. Basically, you're at 64 to this group.
So, we want 4, 47.
classical mesh. The book was
So it's always, the last number always be
you have
But always going to have a range of zero.
That's where it
Get that just to come in good time.
Thank you.
So that's really it.
Zero,
and that's your beta. So you go virtually 92, the regular IP, and then it starts at 0. Yeah, because that's your range from this number. So it's 1 to 0 through 4.8, 64, and then you start at 66. Yeah, you start right now. All right. It's 192.
everything is like
Remember that in my original class, we had
Oh, that's nice.
now, what we work on in my notes, what that means is that essentially, if it helps you to think, I don't know if it's helpful to use music, but I'll try. But some of
How many the problem now is that how many like there is most of them just use we have to survive before. I don't know if they like what we are thinking like for the 2B. And one is second B, the 2O, like I'm sorry.
Yeah.
You don't have to think about that.
I think because he showed it on the video, it's different.
there's a number of different operations. One works on 19. So doing logic with minor. So a hand operation takes two inputs. So what it's all about. Hey, we want to take the test and whatever.
Base 1 and 2. Two base 1.
Yeah.
Okay, so
But you have to do two convert. But how many of these zeros do you want to get 4 subnets? In other words, what is 0, 1, 1, 0, 2? My thing is, so here again, so that means it will start off with 0, and that's going to go up to 4. If you add 64 to 0, you can go over. 64, if you add 0 to 163, you can get all of you. Okay? 64 this, you add here. So 0, 1, 0, 1. We're just going to get
Yeah.
So that's arbitrary value. I need to ask, okay, so what is my most portion of this address? And what is my what my piece of network address wants to go is, please tell me the network portion of this address. So I know what I'm supposed to be sending this to. So what I'm going to do is my subnet. Subnet mask 255.
All right, so we have about 4 minutes left here. So this recording is going to hear a lot of mumbling. So yeah, so just skip ahead till you hear me gabbing again. But it was worth seeing the Oculus stuff. That was like crazy, like cool as anything. All right, so what'd you guys come up with? How many borrowed bits? How many borrowed bits did you guys need? Two, right? 2 bits to form 4. So an easier way to do this is you could say you needed 4 subnets. If you take the square root of that, what do you get? 2. What about if you had 5 subnets and took the square root of that? You get 2 plus 2 point something, and you just go up 1. So you have to be 3, and then if you did 2 to the 3, you'd come up with 8, right? You come up with 8. So even though you only needed 6, you'd have 2 subnets just kind of flopping out there. Okay, so you can't. They can only be in powers of 2s.
So do we not use those, or are they just like null? Or?
They're just kind of like not used, and maybe you might eventually use them. Yeah. Okay. All right. Good. So we came up with 4 subnets. Okay. And what were the subnets? What did you guys come up with? 192.168.20.0 to what? 63. What was the second subnet? 64 to
127.
Third subnet. 128 to 191. 192 to 255. Okay. And then you had 64 possible, but how many could you? You can only use 62, right? Why?
You need to define it.
You need to define it and the broadcast. Okay. So you would have had what? 1 to 62, and then 128 or 129 to what? 129 to
190.
190. Yeah. All right. So you guys got that. All right. So this kind of sort of makes sense.
Yeah.
Is it getting there? You guys kind of sink in?
A little bit muddy.
A little bit muddy, but all right, that's fine. So honestly, if you guys, until you know that, you cannot take the test. I mean, ask Mike, did you know how much of subnetting and stuff like that was on the test? Yeah, exactly. So if you can't do that, it's like you don't waste your money.
Can you put some links? You can't.
I can, or you guys could find them. If you find them, I'll share them out to the class. But Eli, the computer guy, is good. I think he has stuff on subnetting. So some of the good links to go out to is Eli, the computer guy on YouTube, and Professor Messer. His videos are really small. They're like 10 minutes, 12 minutes. I'm sorry? CBT nuggets too, yep. So that's like probably the 3 I would go look at. I think you have quizzes due today, yep. So let's quickly go over IPv6 abbreviation. IPv6 abbreviation. So if we look at this, we didn't even go over CIDR either. All right, so CIDR, all right, so if we look at CIDR, what this does is it allows you to have a single route to shoot out the different networks. So if you look right here, we have a /21, /22, /22, and a /20 network. So if we look at these guys, magic pen. Where'd the magic pen go? Oh. Anybody see the magic pen? So drop it down somewhere. Anybody see the magic pen?
Somewhere.
Might be next door. Shoot.
Put it down while you were sitting.
Subnet it somewhere.
Darn, all right. No, you'll see it's like it doesn't have like a, all right, maybe I left it next door. All right, I need to find that. All right, so, no magic pen. All right. Yeah, but I wanted to record it just so it's there, but yeah, so if we look at old school here on the whiteboard, if you have 194.24.0.0, you can. So if you just wrote these out, 194, that's going to be what? So it's going to be 11000010. So on CIDR, what happens is you just write all these out. You literally write all these out binary. And the place where it all overlaps, there's going to be a place you just put it down there. Those many of bits where they're all repeating, that will define the network. And then the other portion, so that 32 minus that will give you the host portion. Okay? So you actually have to write these out, and the book has some examples. I think I did some examples on the video as well. But that's CIDR, we can cover that. Or look at the video, we can cover that. But if we look at really quick on IPv6 abbreviation, what you can do in IPv6 is you can abbreviate any leading zeros. So right here, this 0, 1, 2, 3, we can write that as 1, 2, 3. Then it'd be 4040. Any amount of clumps you have with all zeros, you could put double colons in there and just leave it and then delete all that stuff out. So on this one, you could say 1, 2, 3, 4040, and you have to know this for the test too. These are test questions. So we have how many clumps of zeros? You have 1, 2, 3. So that's, and you have one set of double colons, and then you have 8 in that next set of 4. You have 3 zeros and an A. So you just write down A, and then you can write down B.
2 colons.
Not 2 colons. Not 2 colons. You only do that when you take them out. So what about this one right here? How can you do this one?
So ABCD.
ABCD, double colon, okay,
40.
and then 4040. I tricked you guys. You can only do a double colon once.
So can you put 0?
But you can't put 0, 0. Okay? And then you'd have what?
Colon C0A.
C0A.
Colon B.
And then colon B. And then if ever you tell somebody, don't ever do this to somebody. Don't ever say as a network person, is that a 0 or an O? Okay? Because they will laugh you out of your office. I would like walk somebody out. Why can't it be an O? It's hexadecimal. It goes 0 to 9 and A to F. It's never an O. Don't ever ask anybody if that's an O. If you do, if they ask who your professor was, never say Cassoni. Okay.
So it's an O, not a zero, right?
Yeah, exactly. Because Sonny, you told us that all the time. You're like fired. All right, good class today. So look at this, possibly reread the chapter. Look at the video. Professor Messer, Eli the computer guy, and CBT. What's the other one, Mike? CBT? CBT Nuggets. Those are all three good ones. Okay. If you guys look at, so Mark Gomez, to answer your question, if you guys go into good information, really great information, if you guys haven't looked at this, I highly suggest you do. There's all kinds of good stuff in here. There's software on the hub, Black Box, TED Talks, all kind of things in there.
And the Zoom link?
The Zoom link I'll get for you guys right now.
You get extra credit for doing that or only yourself?
For what now? Oh, Zoom link. Yeah, I'll send it out to everybody.
You get extra credit for doing that or do you get extra credit only for yourself?
I don't care. You guys can get extra credit for that.
Look at that.